Here we are back for problem 12.6 on page 203. As you probably know, automobile insurance companies consider many factors when setting rates, including age, marital status, and miles driven per year. To determine the effect of gender, they decided a random sample of young male and female drivers, all younger than 25 with at least 2 years of driving experience, and each was asked how many miles he or she had driven in the past year. The distances in thousands of miles are stored in column 1, and then in column 2 it's identified whether they're 1 male or 2 female. And so the first question we're trying to answer is, can we conclude that male and female drivers differ in the number of miles driven per year? So to begin with, we're going to calculate the average, or the x-bar, and this one's a little tricky because what we're averaging is in column A, but it depends on which gender in column B. So x-bar 1 is going to be for males equals average, and we're going to use this average if. So the range is going to be from B2 to B201. And the criteria will be 1, and then the average range, or what we're trying to average, will be over here in column A. And when we do that, we get an average of 10.233. And now we want to do the same thing for female, so average if, and again the range is B2 to B201. We'll come back up here. The criteria this time will be 2, so females, and then for the last parameter, the average range, that's column 1, the distance, and we can close the parentheses, and in that case the average miles is 9.66. Now in the case of both N1 and N2, there's 100 for both of those. And now we're called on to calculate the S sub 1 squared, the variance. And that's going to be a little trickier based on how this is set up. So what I want to do is just come up here and select these two columns, and I'm going to go over here to sort and filter and choose custom sort. And I'm going to do this custom sort on gender, the values, and go from smallest to largest, which is going to put all of the males first, and then we'll do females, but that will allow us to do that variance calculation. Oops, shouldn't have done it that way though. I need the whole column. Custom sort, click OK, and now you see it's ones all the way down, and I can go right over here, and again it's a variance of a sample, so it's going to be equals VAR, and we're going to go here, and now we'll click and drag, and we're going to go down just all the ones, so we'll go from B2 down to B101, and after we've done that, we can close the parenthesis, and didn't work something there, so let me try that again. Oh, I know what I did. I want the average in the A, not the B. Let's see, almost got it. Alright, so we close this and we get an average of 8.225, and for whatever reason it thinks there's an error, so we're just going to choose to ignore that. And now equals V. So again, we're going to do the sample, but now we're going to scroll down and get the distances, but for females. So we'll start in cell A102 and go down to A201. In that case, it's 8.3822. And again, we just want to ignore because it's not really an error. And again, we've got the 100 in there. If we wanted this as the standard deviation as opposed to the variance, we could just go equal the square root and take that just to have it in case we want it. 2.87. So you just fill handle, drag that down, and it's 2.9 for that one. And we'll calculate the f-test right here, which is the s sub 1 squared divided the s sub 2 squared, which gives us 0.9813. And now we can use the f inverse function so that to give us that. We're going to take the probability, which is that 0.025, and then we've got the 99 because it's 100 minus 1 for the degrees of freedom for the first one, and the same thing for the second, which gives us 0.6728. And now we want to do the same thing for the upper end, so f in, but instead of 0.025 we're going to go 1 minus 0.025, comma, degrees of freedom for 1 was 99, degrees of freedom for 2 is also 99, and now we have 1.48. So when we look at this, we've got this f-score that we calculated based on the samples of 0.9813, and then we've got the rejection region based on the calculations given the probability and the degrees of freedom, and the rejection region would be an f less than this 0.6728 or an f greater than the 1.462. And oops, sorry about that. Since the f we calculated as 0.9813 is not in that rejection region, then we will use the equal variances test statistic. So let's keep going, and we're back here with the s sub p squared, that pool variance estimator, which we're going to need again with the t-test down here. So again, it's equal to, and let me do this. I'm going to I can't quite get that to come out. Just 1 second. Okay, here I'm up above the vertical scroll. I'm just going to do the split screen. Now we've got 2 scroll bars. And in this case, back in cell E27, it's going to be equal to n1 minus 1 times s sub 1 squared plus n2 minus 1 times s2 squared, s sub 2 squared, and that will give us 1644.163. And now for the denominator again, and I broke this down because sometimes the formulas get a little complicated and it's harder to troubleshoot them, so it's just a little easier this way to make sure you've got the calculation correct. N1 plus N2 minus 2 for degrees of freedom, so we come up with 198. And then I just simply divide the numerator by the denominator and come up with 8.3039. And you can see over here on this pooled variance estimator, I just spelled that out, what the calculations are actually going to be. And now I just want to perform the t statistic. So again, I'm going to do the numerator, which is equal to x bar 1 minus x bar 2 minus, and in this case we believe the population means are equal, so we're going to go 0 for 0.57, and then for the denominator it's going to be equal to the square root of this s sub p squared, the pooled variance estimator, times 1 divided by n1 plus 1 divided by n2, close parentheses. It didn't like part of it, but it still calculated it for me at 0.407526. And now to give me the t statistic, just divide the numerator by the denominator, and I get 1.41. And now what I want to do is simply do the t-square based on the alpha and the degrees of freedom to see if we fall in the rejection range or not. So in this case it's equal to t, and in this case the probability 0.025, and the degrees of freedom 100 plus 100 minus 2 gives us that 198, and that's minus 1.972. Again, I'm going to do it again for the other part of the t at t, and the probability is 0.02, 1 minus 0.025, and then 198 for degrees of freedom, so the 1972. So if we compare this, the rejection region would be a t less than minus 1.972 or a t greater than 1.972, and our t calculated, the t-stat came in at 1.41. So in this case there's not enough evidence, since 1.41 is less than the 1.972, to infer that the distance males and females drive differ. So that would be the equivalent, and I'm just going to quickly preview this. You can see that I've got this additional calculation down here. I'll have to come back and do that. I'm out of time. So